Is all your homework is due? Passed in to the side? So in number 4, I think this is what you come up with earlier in 4 for the function of how much framing material you need given the diameter. So that length, okay, so the first L is this right here. You're going to have that much framing. And then you have 2 halves of that one and that one. And that's this here. And then you have the curved part, which is half of the circumference. Circumference is 2 pi r, and you want half of that. So does that look good for the function that gives you total length of framing based on the dimension L? Yeah? I know, I'm just setting it up because we're going to need this for G, right? So is this correct? Yeah. Yeah, I'm showing where it comes from. Yeah, of course I can simplify things here, but I'm just showing where it comes from. Just showing the process. Okay. So we need to come up with a formula that will calculate the total cost of the glass for a window that is x feet wide. So the total amount of glass that we have is basically half of a circle minus all the framing material. Is that right? So the amount of glass, we'd start with the area of that half circle would be 1/2 pi r squared. What's r? That should be an L. That's an L. Try it again. Okay, so that's the whole thing, but then we have to subtract. We have to subtract the area for this length. So we could subtract the length, FL, which is this whole thing. To get area then, how wide is it? 1/12 of a foot? 1/12 of a foot. Is that right?
Yeah. So
does that make sense? So it's like you start with the whole half circle, and then you can subtract off the area of all this framing. So I'm just going to take the length of the framing times the width. So this is the length of framing times the width of the framing. So you could just take this thing right there and plug it in there. Now that would be the amount of glass. If we wanted the cost of the glass, then it'd be how much?
17.
Times 17 per square unit, which would be the cost given the dimension L, be the cost of the glass. Yeah?
Could you have done 17 over 2 and then take over in front of the first equation?
Okay.
Or do the function of the length times 17 over 12?
There would be other ways to rearrange this that would be correct. So I'm not,
Okay.
yeah. So I'm not sure.
It's like just like distributing.
Then you distribute this. Yeah. Does it make sense? Those who wanted to talk about this one, does that make sense? So that would be the function total glass of a half minus the area of all the framing, and then times 17.
So the area you get by taking all of your linear footage and then multiplying it by your 1/12.
Yeah. So it's like you're just laying it all in a row. FL is the total length times 12 gives the area of that. Away from that glass. Okay. 18. Which one? B or D? Boy or dog? Dog. Okay. So we got A of 2A minus 3. And where A of X is, so what is the thing over on the right side called? What did we say that is? This is the thing I'm writing right now. That's the rule. What is the rule? The rule is, it's a set of instructions on what to do with the input. So could we just generalize, what does this rule say to do to the input? What does this rule say to do to whatever the input is? What does it say to do first?
Square x.
Square it and then multiply by 6. We're going to take that input, we're going to square it and multiply by 6. What's the next thing we're going to do?
Multiply by 3.
Subtract 3 times the input from that number, and then add 8. And then, once we've got that, we're going to divide by the input. So that's the set of instructions that's telling us to do on whatever the input is. What's the input in this case? 2a minus 3. So we're going to do that. What did we say first? We said we were going to square it first, and then multiply it by 6. See, this is telling us what to do with the input. Now our input is 2a minus 3. So we're going to take that input and square it, multiply by 6. Then subtract 3 times the input. Plus 8. And then we're going to divide by the input. So you got to just see this as one unit, one quantity, one value. That's our input value. Follow the set of instructions that this says to do to the input. And then, if you like algebra, go for it. Have at it. Expand it, combine your like terms, that whole thing. So any questions on that?
Is that all that is the answer?
Yeah, that could be the answer. It doesn't say simplify your answer, so that's perfectly legitimate. If it said put it in simplest form, then we'd have to sit here and combine, multiply everything out, combine our like terms. It didn't say that, so this would be a completely acceptable answer. Okay, we are talking about functions. Functions are about process. Okay, they're about the process of two quantities, input and output. Let's see if we go to the next page. Is it bigger? Not bigger. Okay, can you read these tables? Can you read those? Barely. Okay, so if you can't, they're also on page... One of you is going to find it before me. 102. So just look at the bottom of page 102. Forget about any questions in the book. Just use page 102 for the tables. Forget about all the questions in the book. I got new questions for you. We're going to start off with some review on that. So I want you to, looking at those tables on page 102, or if you can read the screen, here are the 5 questions I want you to work on. Definitely, you can work together with the person next to you. Okay? So just a couple minutes. What's that? Yeah, if you can find some blank space, or if you've got your own notebook, that'd be good. Or if you flip back one page, you got a whole blank page on page 100. That's all blank. Be a good place to do it, or if you have your own notebook. So ignore any question in the book. Do these.
So we have to put that into a function. So f of 7. G of 7. We're going to do G of 7, right? Or G, especially G.
That help a little bit? A little bigger? Thank you, sir. Starts easy. So starts with some just warm-up review, and then we'll move into the new stuff. Okay, I'll come around for a question. You guys good at all? table's function G. So that's what when I said express the function notation, using F and G. F is the left table,
Yes.
G is the right table.
Oh wait, no, I got my
Yes, I think it is
I missed them.
No.
Okay,
Just
how many hours are the shifts when 70 people are employed? How many hours? So we got to pick the right table. Am I going to pick this table over here or the right table? Right table tells me when 70 are employed, input, output is 11.5. So how can I use function notation to say that this is function G? G inputs number of workers each day employed and outputs the average length of the shift. That's how you could do that. Okay, how many hours were the shifts in the year with 7 accidents? As an approximation. I'm going to look at the F function or the G function. Okay, what's the input into F? Is it length of shift or expected accidents? Length of shift. So this is going to be the answer to this question, right? The input is the answer to this question. The output is 7 expected accidents. So we go down to the table, and it's 9-hour shifts on the average result in 7 accidents per year. Is this making sense? This is kind of review, right? Review of homework. Okay. How many accidents would be expected when shifts average 11 hours? That's the F function, right? What's the input? Length of the shift is the input 11, and we're asking for expected accidents 10. Okay, good so far? Anybody have a question on that? That should be review. Now this is a little different. So when 65 workers are employed daily, what's the process you would use to find how many accidents you would expect? Where would we start?
Function G.
Go to G, and we got 65 workers, which would give us 12-hour shifts. Okay, and then
12-hour shifts and go to function F.
12-hour shifts would be now the input into function F. And that would tell us
13 accidents.
13 accidents. Do you follow that? Anybody have a question? So tell me, if we want to do that in function notation, let's start with this. So for function G comes first, right? So G of 65. What is G of 65? 12. It's 12-hour shifts. When 65 people are employed each day, they have to work 12-hour shifts. Do I need to write 12?
No.
No, G of 65, that's what it is. It's 12. It's a representation of 12 hours. So now we go to function F. What's the input?
G is 60.
Yeah, so the input into F now is the 12 hours. We can just leave it as G of 65, do you see? And we're inputting that into function what? F. And the output of F will be 13 expected accidents. Do you see? So the function notation works. It's like taking the output of the first one and making the input of the second. So this is the output of F. When the input of F is the output of G. When its input is 65. Does that make sense? 13 expected accidents is the output of F when the input of F is the output of G when its input is 65. Try that tonight. That's hard to do. If you can only do it if you really understand what's going on. So I've sat with students for 10, 20 minutes at a time trying to do that. It's really difficult, and you'll have that in the homework. Okay, one more time. 13 number accidents is the output of F when its input is? No. What is G of 65? The output of G when its input is 65. 13 is the output of F when the input is the output of G when its input is 65. You're going to get lots of practice of that. Okay, the other one. So if it's 100, what are we going to do with 100 first?
G of 100.
What is G of 100? 8. New color. This thing is so cool. 100 gives us 8, but we can represent 8 with G of 100. We just leave it that way. It means that length of shift. And so now that length of shift will go in. So if we plugged the output of G when its input was 100 into F, it's going to give us 6. Meaning that when 100 workers are employed daily, we have 6 expected accidents per year. Okay, so I kind of did this. This is the answer to number 5. All right, so now what I want you to do is answer those questions on the next page, which is what, 103? A, B, and C. On just A, B, and C on page 103. Work on those. Talk these out. Talk out what those expressions mean. What's that?
What is real world value?
Real world value. Does it make sense in a real world context? Yeah, so it's just saying, does it make sense? Okay, so for A, does it make sense?
Yes.
What'd you get for an answer? 8 accidents per year? So let's break that down. What does the 80 represent? Okay, if we're using the function g, that input into g has to be what kind of quantity? Average length of shift, number of expected accidents, or number of workers? If it's the function g, what does g do? It takes a number of workers. And what's its process? It tells you average length of the shift, which was what?
10.
10 hours? And now, what does the function f do? It receives hours for the shift. It's the only thing it accepts. It will only accept the length of a shift. And given the length of the shift, it will spit out an expected number of accidents over the course of a year. So f of 10 is the 8. Part B. They said g of f of what? 9. Okay? What is the 9? This is the length of the shift in hours. And what does f output?
Accidents.
Number of accidents. Okay? Which was, in this case, how many? 7 accidents. Okay? So what does g do? G takes... Does it take the number of accidents? No. What does it do to the number of accidents? Rejects it. And says, no, I'm not taking that. That's not what I do. That's not my function. That's not my function. My function is not to work on a number of accidents. I don't know anything about a number of accidents. It's not my function. Does that make sense? So you can't put number of accidents into G. Okay? We're done. This is a, the machine shuts down. The G machine just says, nope, I reject that. The G machine only takes number of workers. It doesn't know what to do with the number of accidents. So this doesn't make sense. G does not operate on that. That's not its function. So if you put no answer, does not exist, for B, you're right. So in this context, F, this is called composition. F of G makes sense because the output of G matches up with the input of F. But the output of F does not match up with the input of G in terms of what that quantity means. So it can't do it. Doesn't make sense. And then, so what does the value 13 mean in part C? We actually already did that example, right? So 13 is the output of F, and we'd be asking for the input of G, or the number of workers that would result in 13 accidents per year. So what was the answer to? It's the one we did. They're just going backwards now, 65. So the blue one there. The output of F is 13, which gives us a length of shift of 12 going into F, or coming out of G, which would be the 65 workers input into G. Okay. So what we could do is, so far what we've been talking about is looking at this as a string of two processes. What goes into G, what comes out of G, then can be put into F, and then we get an output of F. Could we make a table that will just take us straight from number of workers a day to number of expected accidents? Could we make a table like that and just make it a streamlined process of one step? Could we do that? We sure can. Okay, so we're going to do that. So what did I say? So we want a number of workers. We'll do it fast. And we want the output to be number of accidents expected. Workers per day? Yeah. Oh, that wasn't a good line. Okay, so when the number of workers per day is 60, what's the number of accidents?
18.
You see that it's 18. When the number of accidents is 80, sorry, number of workers in a day is 80,
8.
we expect 8 accidents. 90, 7, 100, 6, 120, we don't know. I mean, we could kind of estimate. Okay, so here is one function that has the same result as this process. So this, writing it this way implies a process of 2 steps. Plug in the number of workers, get the average hour of a shift, take that average hour of shift, plug in the other one, get the expected accidents. Whereas this just streams like we could call it function, say, S. Okay? Or whatever we want. So what is it? It's like an accident function. So let's call it A. So let's call this accident function. So A, which is represented in this table here, is the one-step function that does the same process as those in succession, taking the output of G and putting it into F. Does it make sense? So what's A of 90? 7. What's the input into A? What kind of quantity goes into A? What is its function? It takes
Number of workers.
number of workers, and what does it output?
Number of accidents.
Number of accidents. Okay? So it bypasses the middleman. Bypasses the middleman, does it efficiently. Okay, what I want you to do now is flip back a little bit. Any questions on this? So this is called composition of functions. When you take the output of one and make it the input of another and make like a string of 2 processes together, this is called composition. Composition of functions. So there's 2 ways to think about it. The one way is we can think about it as the 2 steps. Figure out the one, take the output, put it into the other, get the second output. That's totally legitimate composition. Or we can create the one streamlined process. Okay, that's the composition. A is the composition of F and G. A is the composition of F and G. 2 ways to think about it. Okay, so I want you to, I got the instructions right here. On page 102, I want you to, so read number 4. No, that's not right. Sorry, we already did that. 97. So read the problem, number 3, then flip to 98, and then do E first, and then do D, go back, and then find the area after 3.5 seconds. Okay, so does it make sense? At 97, you're going to read the description, number 3, then you're going to skip and start by doing E, and then go back and do D, and then find the area after 3.5 seconds. So read the description slowly, think about it. Okay, it'll take you a little time. Got to get those E. We got to get E right. So if you want me to check your work on E, I can check your work on E. As a function of, in terms of, so that matches. And also describe a function as the name and then just the input, so it's just faculty. Then we need the rule. The rule is what do we do to T to get the output, which is the radius. Nope. Since you just want the radius as a function of time, nothing to do with area data. What is the input? Radius as a function of time. T is the input. So it's what you're going to do.
Just
So where is it?
the radius of the
Also, unrepresented.
just measuring the radius itself. So where is it? Yeah.
How is unrepresented?
It would just be.
That's right. That's the whole thing. Is FOT. R is FOT. The output.
Yeah, that's a good term.
Yeah, so would you that is radius. So that's the speed of the ripple. So after 1 second, so it's just whatever. Rule on T will give you the radius. What do you have to do to T? Get the radius.
I did G of F equals I.
Wed Sept times
So it's kind of like using references. So like you could just use the F function inside the G function. F function stands for the radius.
that math. There it is.
Pi F of T squared.
So when we say one thing is a function of another, we're saying the output is a function of the input. Output depends on input. Okay? So what's our input going to be here for F? So F is the name. What depends on what? Does radius depend on time? Or does time depend on radius?
Radius depends on
Radius depends on time. We want radius as a function of time. A function of time. Right there. Just read it. A function of time. So we need the rule. So what does f of t represent? That's radius. That's the output. That's radius. It's the output. So we need a rule. Given t tells us what r is. So what rule? So after 1 second, what's the radius? 0.7. After 2 seconds, what's the radius? 1.4. After 3 seconds, 2.1. So what's the rule that gives us radius from time? Yep, 0.7, 0.7 t. Okay, that's our radius function. Then we have an area function. So if it's area as a function of radius, what's the input? Area as a function of radius, what's the input? Input is radius. Area as a function of radius. And what is g of r? What does that represent? The output is area. So it's area as a function of radius. Radius as a function of time. Do you see? What rule gives us area by operating on the radius? What rule do we need given radius that will give us the area? It's a circle, right? That's it. Pi r squared. So if you knew how much time went by, how would you find the area? If you knew how much time went by, how would you find the area? Tell the person next to you. Take 30 seconds. If you knew how much time, so say after 3 seconds, how would you find the area of the circle? It should feel familiar. Does it feel familiar? What is it like? The tables that we just did, right? If you know the time is 3.5, what do you do first? Okay, you guys, can you... We could put, okay, so if we know the time, can we put time into the g function? G takes radius. G inputs radius. It rejects time. So, but f will give us what? It'll give us the radius, which is 2.45? Thank you.
Is this the question?
Nope, this is the one I made up here. Put in, so what I'm saying after 3.5 seconds, the radius is 2.45. Now how do I find the area? Okay, so this is really important stuff. If you're working on the math, please whisper, but the socializing's gotta stop. Okay. So we got the time went in, 3.5, gave us the radius. So how will we find the area now? We're going to use g function, okay? We'll take g, and we'll take 2.45 and put it into g. And it'll be pi times 2.45 squared. Anybody got it?
Yeah. 18.86.
18 point, I'll round to 9. And this is what, inches, centimeters, was it?
I think it's meters.
Meter squared?
Yeah.
It's the same thing as before. The f function will take time and give us radius. Then the g function, we take the output of f and put it into g. So will that be g of f, or will that be f of g? Which one? This one is the one that works. This does not work, because the output of g is area. You can't put area into f. You need to put time into f. But this works good. Okay, real quick. So what comes first, f or g? F comes first. What goes into F? What comes out? Radius. Then G. What goes in? What comes out? What about one function? Okay, if you want to leave, that's cool. Just don't talk. How about that? All right. So what if we want one function, and the goal of that function would be to input and output area. So what was our rule? This was f of t equals 0.7t, and this was g of r equals pi r squared. So this is r, right? So we could put that into that, which would, what are the set of instructions? Pi r squared. We could, so this is r, and we can put r there. So what is the one rule that does both? Pi times 0.7t, that's r squared. So that's the composition as a one-step function. It's a one-step function. You put in t, that formula will crack out a in one step. That's the composition as a one-step. Okay, see you Friday. Maybe a quiz on Friday, maybe. Any ideas and more problems? Yes.
Yes, the day when you said that, remember the function, what was f of